Hello, this is question 8 on your AS level paper from June 2022 from Edexcel. You have the air pressure, P, kilograms per centimeter square, inside a car tire. 10 minutes from the instant when the tire develops a puncture is given by this equation. Yeah, it's an exponential equation, where K is a constant. Given that the initial air pressure inside the tire was 2.2, state the value of K. Initial air pressure is when T is 0. So what we are going to do is to find K using that information. Yeah. So A, the initial pressure is 2.5, is going to be K plus 1.4 e to the power of 0. Yeah, which is 1. So K is going to be 2.2 minus 1.4 is 0.8. That's my value of K. Yeah, just doing that. Then from the instant when the tire develops the puncture, find the time taken for the air pressure to fall to 1 kilogram per centimeter squared. Give your answer in minutes to one decimal place. So we now know that the pressure is 1. We know this constant and we need to find time. So we have that 1 is going to be K, and I'm going to write now my value, plus 1.4 e to the power of minus 0.5 t. And I need to find t from there. I can put the numbers all together. So I have 1 minus 0.8 is 0.2 divided by 0.2 divided by 1.4 is going to be e to the power of minus 0.05 t. And taking ln, I have ln 0.2, 1.4 is going to be minus 0.5 t, which means that t is all this value here divided by, which is negative, divided by minus 0.5. I just do that with the calculator and I get 3.891 something, and it says give your answer in minutes to one decimal place. So we are going to round that to 3.8 minutes. Remember, all the questions that are modeling something and they give you units, give your answers with the units. Even if they don't tell you, they are going to remind you many times, but if they don't, I would still write the answers with units. Then C, find the rate. This word is key for these modeling questions. They are asking you to derivate the function rate, because the derivative is giving me the rate of change. So find the rate at which the air pressure in the tire is decreasing exactly 2 minutes from the instant where the tire developed the puncture. So I'm going to find the derivative, and then I'm going to find the value of the derivative when t is 2 minutes. Yeah. So C is going to be the derivative of P with respect to T. This is my function. So when I derivate this thing here, this one is 0, then I have minus 0.5 times 1.4 and the same function. So it's going to be minus 0.5 times 1.4 and the same function. Remember, this is how we derivate exponential. So when t is 2, I just substitute the t by 2 here, and this value is 0.2575, and they ask me to give your answer in kilograms per centimeter square per minute to 3 significant figures. Yeah, 3 significant figures. So that is going to be 0.258 kilogram centimeter squared per minute. Check if all the units are in the right thing, but you have the time in minutes and the pressure, just in case. Sometimes they ask you, instead of minutes, seconds or something like that. Check that you have, but you have 2 minutes and they ask you the answer in minutes, so that's fine. Yeah, and that's your answer. Yeah.